Hello. I can't hear you. Can you hear me? Hello.
Yes,
Yeah, yeah, I can hear you now. All right, good. All right, let so today will be like a small short class for 45 minutes. We can start straightforward. I do made some notes from our the cheat sheet that has been provided. Okay, and the term that okay, what we are going to today is we will look for like motion terms. What is distance, displacements, velocity, accelerations, then the graph of motions, how these probably the graph of motions hasn't been asked in any exams, past exams, but still we can see that if it is there, we should be knowing about these things. Then we will see the three kinematic equations, and we will apply equations with practice problems and reinforce with past exam questions. All right. So by the end of this, I believe that you should be confident enough to choosing the correct equations for a situation, solving step by step, explaining why you choose it. Okay. Uh, the important thing is that uh, you should be able confident about choosing the correct equations. Okay. And if that's you can attempt correctly, most of the part is 80% of the part has been done. The rest of it is just the calculations. So that's the main thing that I have to emphasize on this. Okay, let's do mechanics is about describing and explaining motion. Before we can understand forces, collisions, or energy, we must first master how to describe motion itself, right? So it in for motion, to understand the motion we have to understand some vector and scalar quantities. So you know vector and scalar quantities? Correct. Well, we have talked about yesterday, right? So there are like couple of terms that we will using simultaneously: distance versus displacement, speed versus velocity, right? And then there is an acceleration, right? So distance is how far something travels, right? For example, if we are here from point A, so oops, again. Okay, let me fix this one and then I will get back to you. You're not able to see my screen. You can't see my screen now? Okay, let me fix that one. You can see it now, right? Okay, cool. So now it's clear? All right, let's do this one. Okay, as you can see here, we are at this point A, right? And we have to move to here, right? B. So distance is how far something travels. That means it can go from A to B in a straight line, or let's say if it goes from A to B in this one. You see that? So the distance will be different in both the scenarios. Distance, I think I have to write it down like this. Distance will be different in both cases, right? However, when we are talking about displacement, so displacement is how far and in what direction it ends up from the start. So you can walk in circle for 1 kilometer, but still have zero displacement, right? So if I'm saying like let's take this example. Is this a circle? No, this is a potato. Okay, let me try to figure this out. Okay, this seems a bit a circle. Okay, so if I say distance, then if the radius is r centimeter or meter, then the distance will be the circumference, 2 pi r, right? But the displacement, according to the definition, will be 0 centimeter or meter, whatever it is. Okay, so because, and now we have to also mention the direction. So displacement is a, here I can put something like this. Distance is a scalar quantity, right? It's a scalar quantity, and displacement is vector. Perfect. All right. Now, next is speed and distance. So, speed is how fast something goes, velocity is speed with direction, right? So, speed, how fast something is traveling, and its unit is meter per second. Okay, and then velocity is speed, speed with direction, correct? Speed with direction, right? And it's also something like meter per second north. We need to mention the direction in here. Okay. Now, the third term, or the, we can say the another term that we are considering here is acceleration. Acceleration. I always forgot the spelling. Okay. Okay. So acceleration. That means change in velocity in each second. Right. What does this mean? Right. So when I'm saying change in velocity in each second, that means we are talking about rate rate of change of velocity with respect to WRT is with respect to time, right? So now rate of change of velocity, we have to understand this term rate of change of. So rate means the difference between the velocity initial or final with the time itself. Okay, so let's say if in the start if a car is traveling at let's say 60 kilometer per hour, right? It looks like 60. Let's say it's starting from here, it's 50 kilometer per hour. Okay, after t time, like let's say 30 minutes, right? It's now traveling in the same direction at 70 kilometer per hour, right? So now if we are understanding, and then we are how we are denoting these quantities as a for acceleration, right? We are using v or u, right, for velocity. Similarly for speed is small s, and for distance and displacement sometimes we use d, or sometimes we use capital S. Okay, so according to the definition, if I have to check the acceleration a, that means we have to check the final velocity, or we need to check the difference between the final and the initial timing, and then we have to see over the time, the t final minus t initial, right? So it can also be sometimes written as delta v over delta t. No, this is not vertical and horizontal, this is final and initial. I'm writing down here. So when I say vf, that is final velocity, right? When I say vi, I should have, when I say vi, it means initial velocity, right? So why I'm saying f vf and vi, so it's being like quite easy to understand. Sometimes in some question papers it is represents, because they don't want to subscripts kind of thing, so straightforward like v, they mention the final velocity as v and the initial velocity as u. Okay, so this need to be taken care of, that whenever you are using some equations, you should be remember these notifications as possible. Okay, now come back to the question itself. Because we are dealing with kilometers and hours, so first we have to understand the conversions in our units, right? So uh, we can say half an hour, right? So if I'm saying A equals, what is the final one? It is 70. What is the initial one? It is 50. Initially, the time we always take t initial is equal to 0 because we haven't been calculating, right? And, then it will be like 30 minutes. So 30 minutes will be like half an hour, right? So now we have to see the acceleration equals 70 minus 50, 20, and then we have half. Okay, so remember how to solve these fractions? Uh, so whenever, let's see, if x equals a over b, which is also being divided by c over d, right? So it is something similar to a over b times d over c. Okay. Now, if there is no mark or no division, we can assume that this is divided by 1. Okay. Now, I'm saying A equals 20 over. I'm just going with the layman kind of thing, okay? It's because as you can see that we have seen that there must be some. You have already said that you haven't been confident in the algebraic expressions kind of thing. So I'm just giving you some sort of taste that what is expected. So this will be 20 times 1 over 2, 2 over 1. Okay, that's what I mean over here. A over b times d over c. So whatever the denominator, it will become numerator over the next term. Okay, that will be a equals 40 kilometer per hour square. Okay, so remember that, and we can also check our units or the answers, if I must say, is here 40 40 kilometer per hour square. Okay, so this is the correct way. So now you have a bit of taste of what are these terms are, right? And okay, now mini check. If a car drives 5 kilometer north and 5 kilometers south, what is the distance? Yes. Okay, let's see why it is. The question says the question says a car moves 10 kilometer 5 kilometer north, right? And then 5 kilometer south, downwards and upward, right? Total distance is total distance traveled is equals to 10 kilometers. But what about the displacement? Perfect. So now you know that what the terms mean exactly, right? Okay, cool. Now come to the next topic, which is, even though it is less significant, but because it is there, so we have to be uh, doing this one just for the sake. Uh, if a question arises, you are able to attempt these questions. Okay. So motion graphs. So we there are like two graphs that we are going to say. One is the displacements and time graph, right? And the velocity and the time graph. So there are two. And what is the significance of these graphs? So let's say, so you know how to draw the graphs. We have y-axis and x-axis, right? So this is a x-axis and this is a y-axis. So when this they say that this is a displacement time graph, so time will always be in the x-axis. Time will always be on the x-axis. It is moving from, and this connection juncture point is 0, 0. Okay, cool. So let's talk about displacement. So this will be the displacement. Displacement. Okay. So let's say, so over the period of time, if it is like going, uh, like say, come up like this, right? So what does also, to understand these graph, you should know that mostly these are like line graphs. Okay. And line graph, there are two things which is important. One is the equation. So this is a line graph. For all the values of x, this is true for y. Okay. I believe that you have seen it somewhere in maths class. So this is just a recap of it. And here, so C is y-intercept, right? M is, you remember what is M? Okay, no worries. M is the gradient. Okay, gradient. And what gradient is the slope. And what's the y-intercept is where this line, if I take back y-axis, right? So it is the value of this distance from here to here. Okay, so this is C, and the slope that we are talking about, parallel to the x-axis. You can see this theta, and how tilted this line is as with respect to the x-axis. That is the gradient. Gradient is also known as tangent of the theta. Tangent of angle. Tangent of angle theta. Okay. So most of the time you have to just mention in physics perspective, or just to regard with this motion graph concept, right? This we are taking account because we have to understand what the gradient is, and when we are dealing with displacement time graph, what the gradient means. So when I'm saying displacement time graph, you are catching things in this format. Okay, cool. That's a nice thing. Okay, displacement time graph, the gradient of the equation represent the velocity. Okay, this represent the velocity. The tilt of the graph gives us the velocity of that particular motion. Okay, next is velocity time graph. So we have our y-axis. Oops. And this is our x-axis. Always represent x and y axis. Okay, when you are about to solve those questions, if someone asks in the graph in any chapter or in any subject, whenever we are dealing with graphs, always label it correctly first, right? X-axis, the y-axis, and the 0 0. This is a two plane graph firstly, right? And this is called, and in again in the x-axis we are representing the time, right? Say in seconds. And in our y, no, so in our velocity time graph, the y will be representing the velocity. Okay, velocity, right? Again, it will be gaining, right? We do have this y-intercept, right? Here now the two things happen. One is this area which is covered by this line from here to here, from here to here, right? So this area, so now there are two things now which is representing by velocity time graph. One is the gradient. Gradient equals acceleration of that motion. It's representing the acceleration, and the area under that graph, area under the graph is equals to displacement, right? So the two terms which will be denoted or which can be expressed, which can be shown in our velocity time graph is the acceleration and the displacement. No, the displacement is this area. Okay, so if we calculate this area, we can say that how far it has gone. We don't need this, but it's just like an call. We can say that if somebody asks that what does this mean, so we can say this area, this area will give us displacement, right? is a much more like mathematical concept, but we will come to this if we are pretty much interested in solving the mathematical concepts of that why this is displacement under this area. It's depend upon the differentiation and the integrations. Uh, Fortunately, you haven't taken the calculus, so it's in the maths part. So we are not dealing with in this detail or stretch that what is happening here. Okay, so in this graph, there is also a point. Think of a slope as telling us how fast velocity is changing. So now there are two things. One, the car or any component or any system is moving, right? Then we have to record how fast or slow it's getting over the time. So if we are saying that how fast or how slow it is getting, or reducing the speed or the velocity, we should say the object is accelerate, either it is accelerating or deaccelerating, right? Right. The area under the line tell us how much ground has been covered. That's the displacement. The area is showing us that how much ground it has covered. Okay. Okay. All right. So this is a simple calculation that if we are saying what is the gradient, again, we just need to say if there is a graph and if it is asked that what will be, let's take this example, right? So it says in velocity time graph, car is accelerating from 0 to 20 meter second in 10 second. In 10 second. So we can again say that what will be the gradient. So gradient is the acceleration, right? Gradient is the acceleration or acceleration, which we know that the difference of the velocity over the distance of the time, which gives us, we know that it is like 20 minus 0 over 10, right? So it will gives us is equals to 2 meter per second square. So this is will be the gradient. We are not with the area, but it's still we can say that this is the acceleration. Okay. Now uh, we have 5 6 minutes more, so we can just cover up these equations. Okay, and then we will tomorrow is Thursday, right? So tomorrow we will do the practice questions. All right. Okay. So the topic will be kinematic equation. Why it is not showing here? Okay, equations. Sorry, we have already covered that up, right? Yeah, yeah, yeah. So this is like the fourth equation that you're talking about, right? So it's just like from the definition it has been derived, okay, of the acceleration. Which, Distance. Okay. Yeah. So again, if we are saying distance, it will always be, let's say, d. In here we have seen s, so let's take an s. uh, s equals, we remember we have the unit as meter, right? So if we can say that it will be like speed over time, right? Mostly this is speed over time is the distance. So speed's unit is meter per second, time unit is second. As we have already seen that for the unit section we can say meter per second times second over 1, it is cancelled out, so this will remain the meter, as we already know. So the thing is that speed is sorry the Dis- distance is speed, or we can say speed over time. Okay, but it will be happening when we have no acceleration. It is the constant speed. So we can say that the initial speed is zero. We will see that thing, right? If we have uh, speed over time. Yeah. Okay. Cool. Am I corrected? No, sorry. My mistake. I'm taking this back because it's not relating exactly what the meter is. It's distance is speed times time. This is the equation. My mistake, sorry. Right? So once I play, so this is a cross check about how we can check the equations regarding related to units. If it is not coming up, that means the equation is wrong. Okay. So S is V times T. Now we can say in respect to our units. So times unit is second, and speeds unit is meter per second. This will come up. This will remain as our meter. So that means that's the distance traveled uh, with v as our final velocity or the speed, and within the t time. Okay. All righty. Now let's take an example of, now the key word is when acceleration acceleration when the acceleration is is constant. What does this mean? That's what we have to understand. When acceleration is constant, it's the same, correct? So in a constant acceleration, right, there are three equations. If the acceleration is changing, that means a car is moving from, like, for 10 minutes it's going from 0 to 60 kilometer, and then reducing, and then coming, then come reducing, then speeding up, then these equations might fail. Okay. So we have to be uh, looking out that we have to be make sure that the question says constant acceleration. If not, even though we assume that the questions which will be asked will always has a constant acceleration. Okay. Now, let's take an example of first. Now, we have to understand these terms first. V equals U plus A T, right? So this, what does this mean? It's connects velocity, time, and acceleration, right? So, for example, if a question says that the acceleration or the car accelerate from 0 to 5 meter per second square in 10 seconds, right? What is going to be its final velocity, right? So the question itself says 0 to 2 meter per second square. It accelerates from steady means zero, so the initial velocity will always be zero, right? So the final velocity v is equals to 2 meter per second square and times I asked 10, right? So that will be 20 meter per second. You have to make sure what the question is asking, why we have taken u equals to 0. It always says that from steady, or it will mention 0 to some like final velocity kind of thing. Yeah, stationary, steady, right? From rest, you can say. So this will always be the terms that we are looking for while solving this question. Okay. Now the second one is the displacement is equals to ut plus half at square. Okay. Now here we do not have the final velocity. We have initial velocity, we have acceleration, right? And then we have time. And what has been asked, or what is the result of these, is the displacement. This is a relationship between the initial velocity, acceleration, time, and displacement. We have to see that because what value has been asked, this is also go back to our strategy that I have listed yesterday. Remember? I will send these things, right? I will send you this, and you have to put it down of your own, and then we will see. Okay. So this is where this comes handy. This particular 7 steps comes handy if we remember this. Read the problem, make sure you understand all the words and ideas, right? So if the question itself says that you have to ask the displacement or initial velocity or the final velocity or the acceleration or or the time, so if you do not understand any of those terms, you are unable to solve that, right? So that's the main focus. First you have to understand those terms. Cool. Now the third one is v square is equals to u square plus 2as. Which terms is missing here? No, displacement is here. Time, correct. So if we do not know, right, about the time, how much it takes to reach some from A to B, but there is a distance or the displacement is given, right? We're still able to calculate if the acceleration or the final or the initial velocity has been given, right? So this relation gives us connect velocities, whether it is initial or final, with displacement and acceleration. All right. So always choose the equation that includes the values you know and the one you need. Cool. So this is so till now I think that we have some sort of understanding that what sort of questions being asked in relation to kinematic equations. They will give some certain scenarios, and then they will give some they will ask some values need to be calculated on the basis of the equations and find out we need to the most important thing is we need to understand what has been given, what terms has been listed, what has been asked, and then we can figure it out what formula or what the equations that we are using. Okay. All right, kiddo. So we are stopping at here. It's almost like 5 minutes more than the usual. It's almost like 1 hour, but still, I will charge like 45 minutes only because I mentioned to your and I have to go around. And once I will send you these 2 days notes once I return back from the class from my son's pickup. All right. Anything else? Okay, so homework is can you list all the questions which is related to these 3 equations or 4 equations? You just make a list of those. I have the list, but I want you to go through with all the papers and see which questions you can list it up. Okay, and then we will sort it out one by one through these notes. What past question paper has questions related to these equations? Yeah. Okay, and list it out like question, let's say one, part A in the question paper 2021, something like that. So you have to mention those, and then you can email me, and we will clarify those questions and answers. All right, not much more than that. Because we haven't done these equations. So once we've done these equations, I will definitely give you more. All right. Okay, Jessica. See you, beta, and see you tomorrow. Bye bye.